Okay, ladies and gentlemen, here's what we're going to do. Let's go with 1/2 inch equals 1 full foot. That way our model is only going to be about yay big rather than something that's a little harder to handle. Now, the very first thing you'll take a look at here is I need to make sure I have a certain height on my walls. The true height of the walls is going to be 10 feet. So if I have 10 1/2 inches, well, what's 10 times 1/2? That's going to be 5. So you'll notice right here on my T-square I have 1, 2, 3, 4, 5 inches. So bring it down. Now, here's the joy about working with a good square and a good set of tools. It makes your job a whole lot easier. So I can go ahead and set the square, and because I know that this is a good right angle down here at the end, I know that this edge and this edge that I just cut are going to be parallel. That means they're never going to touch. They're at the same angle all the way along. Now, the other thing I can do is I can make a couple marks. Again, if I have a wall that's 14 feet long, 14 1/2 inches would be 7 inches. And if you don't believe me, here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I need a mark right here. I need another 7. That's going to put me right here. Then for the 16-foot wall, how many inches is that going to be? Well, 16 halves, 8. So I have 8 inches here, and that gives me 8 inches to the end. Now, we are going to have to make a small adjustment here at some point because we're actually going to have to take into account the thickness of the foam core. But we'll get to that here in just a few minutes. In the meantime, we're going to score it and cut through the paper on each side for our two 14-foot walls. Then we have our 8-foot wall, or our 16-foot wall, which is 8 inches down here, and automatically have 1, 2, 3, 4 walls. Now, for those of you that aren't familiar with working with foam core, the easiest way to work with foam core, or really a lot of plastic or foam materials, is you cut one side, bend the other. If you've ever seen a airplane show called Flight Test, Flight Test does the same thing. In fact, they build entire flying airplanes, model airplanes, out of similar stuff. So once you have this, all you have to do is bend it and score the other side, and there's a wall. So here we go again. Now, with that in mind, there's our 4 walls. We also need the triangles, because if you'll notice on every roof, you have a roof and at the end is a triangle to make what's called the gable. Now the gable end, we know how long it's going to be because it has to be the same 14 feet long as our wall, otherwise it doesn't work. So what we're going to do is we're going to go ahead and mark in 7 inches right up here. Now you also notice I marked it at the top. I'm going to mark it at the bottom as well, so that I have a mark top and bottom. Because between any 2 points, if I connect those points, whether I have a square or not, that's guaranteed to be a straight line. So with that, that's going to be the base of our triangle. Now, here's the problem. A roof has a certain slope. Now, just like slope is rise over run, so slope in algebra is rise over run, we have a slope with our gable ends as well. That slope is going to be an 8/12. That means for every 8 inches we go up, or every 8 feet we go up, it's 12 feet in length. So if I have an 8/12, now let me switch over here so maybe you guys can see it a little better. If I'm looking for something that is an 8/12 pitch, that's my slope, and I know I only have a run of 7, then that means that I need something, a different height that I'm going to be looking for. Now, let's be clear though, if I actually want to make a triangle, I don't have all 7 inches. What I actually have is only half that distance, 3.5 inches. So at 3.5 inches, I could find X. The way I could do that is I would cross multiply, just like we learned how to do in algebra. Now, I'm not going to do it that way though, because that's not the way a carpenter or a craftsman do it. What they would do is they would use their square. And I would set one end, if it's an 8-12 pitch, I'm going to set 8 and 12. So 12 down here on this end of the square, 8 down here on this end of the square, and I can mark a line just like that. And now I know that the slope of this line is going to be 8-12. It's coming right from that corner. I know I have 7 inches long, or 7 feet in real life. So what I can do is I can come down here and do it again as well. Now, if I can't quite get my 8-12 here in the corner, I can do one of a couple things. Number one, I can extend that line so that it's more useful. The other thing to remember about an 8-12 is that I can cut a ratio in half. Regardless of what ratio I have, 8/12, I can take and I could call that a 4/6. So that's in fact what I'm doing here, 4 and 6. And I'm drawing that. That's how a carpenter would lay out a set of stairs, or they would lay out a rafter, or anything else that's going to be on an angle. It's using nothing but the measured sides of something that I know is a right angle. So that becomes kind of important. Now, with that, we can go ahead and cut this guy out. Now, once I have one, I don't need to measure the other one. What I can do is simply copy it again and cut it out again, using one as a pattern. Now, with that, I have one end of the roof and the other end of the roof.